In this section, we are looking at measurements, how to express measurements and different systems of measurements, and then how to convert from one unit of measurement to another. So if we look at measurements, there's a couple different types of measurements. Quantitative measurement, if you think of quantity or amount of something, quantitative measurement is going to involve a number. Qualitative measurement is looking at quality, so a description of something. Quantitative, if you are measuring, is probably going to be more factual, whereas qualitative, or if you're looking at the quality of something, might be a little bit more of an opinion. If I ask you the quality of food at a certain restaurant, that is your opinion, rather than if I said, what is the weight of the burger that you receive at that restaurant? You would have to measure that and give me a specific number. A unit is going to be something that we're going to be able to compare different sizes. A set unit would give us an idea. So if we were looking at pounds, we know how much 1 pound would equal compared to a kilogram. A standard is going to be something that we're going to base our units off of. So if we think of a year is based off of one trip of the Earth around the sun, that standard is the time it takes for that trip, whereas the unit would be the year. There are a couple different systems of measurements. The first system we're going to look at is the English system, and this is actually what we use here in America. So feet, inches, pounds. But there's not really any nice connection with these different units. So 1 foot is 12 inches. If we were comparing that to meters or miles, there's all different numbers that are making those connections. So it's just basically something that you have to memorize, how different units in the English system are related, ounces and pounds and things like that. This system is used in the United States, and there's a couple other very, very tiny countries that use it, but almost everywhere in the world uses what's called the metric system. And this system is far easier because it's based on units of 10. If you were converting from one metric system, maybe as far as meters to centimeters to decimeters, all of those are going to be in increments of 10, 100, 1,000. So this was developed in France in the late 18th century. And like I said, almost everywhere around the globe uses this metric system. Why might the United States not convert to the metric system? We've tried to do this before. A couple of different things. We're America, right? So we would like to do things our way. Also, if you think about the cost that would go into switching from English to metric, it would be rather expensive. Looking at changing all the road signs, changing of all the measurements, even on all the products at, let's say, Walmart, all of the different units would have to be changed from English to metric. So it would be quite costly. Then we have the SI system, which this is the system that all of the scientists around the world use. They have agreed upon units that they're going to, use for different measurements. So when a scientist measures the length of something, they will always use the meter because that's the agreed upon measurement in science. When a scientist takes the mass of something, they're always going to use kilograms. When they are taking time, they'll always use seconds. When we're looking at mass versus weight, this is something that should be talked about in grade school or junior high, but our terminology that is used in everyday language sometimes makes the two a little bit confusing. So first of all, mass is the amount of matter or the amount of stuff that makes up an object, whereas weight is how much does gravity pull down on that object, whether it's gravity on Earth or gravity on the moon or another planet. So weight will change depending on where you're located in terms of planets or the moon. But mass is always going to be constant. SI base units. So going back to that SI system, these are the units that are agreed upon by scientists to use. And this is something that I will ask multiple times on tests this year, next year, and going further. So I might ask a question, what is the SI unit for length? And you would tell me meter. So you need to be very familiar with these. So mass is a kilogram. Time is the second. Temperature is Kelvin, which is something we'll discuss later. Most people are familiar with Fahrenheit or Celsius, but science uses Kelvin. And then amount of a substance, the unit is the mole. When we think of amount, we might think of a dozen. That tells us 12 of something. Where in science, we're using a mole. This chart you will be very familiar with. I will give you a physical copy, but this is kind of what it looks like. So SI prefixes, these are prefixes used in the metric system to mean different amounts. So in the English system, we're used to feet and inches to mean different increments in size. In the metric system, those units of 10, some people might be familiar with a centimeter or a millimeter or a kilometer. Those are all prefixes put on that base amount. So a base amount might be a meter or a gram or a liter. And so any of these base units could be used with these prefixes. So one thing to look at, when we start doing conversions, one of the prefix amount, so let's say 1 centimeter, is going to be equal to the multiplying factor of that base unit. So for example, the 1 centimeter would be equal to the 0.01 meters. So if we look at conversion factors, a conversion factor is basically a ratio expressing the comparison between one unit and another. So if we were to say $1 equals how many quarters, that's the comparison between those two amounts. So $1 would equal 4 quarters. 1 foot equals 12 inches. So the conversion factor there would be 1 foot to 12 inches. We could then use those to convert different amounts, like ratios. So if we know 4 quarters equals $1, 7 quarters will equal $1.75. So now we're going to look at how to do some of these conversions. So here we've got 5.712 grams, and we want to convert that to milligrams. So we'll always start off with the unit that is given with the number, and we're converting it to the other unit that's given. You will have this chart. I will upload it on Classroom, but you should have your hard copy as well. So that's a document that you want with you at all times. You will be able to use it on tests. So I'm going to be switching back and forth between these two screens. So if we start out, first we're going to be starting with 5.712 grams. And then you're going to draw a multiply sign. So this is very similar to a fraction where it's over 1, but we don't write the 1 because that's understood. But then we're going to draw another line like we're setting up another fraction. So whatever unit that you're starting off with is going to go on bottom in the next step. So we started with grams, so we'll put grams on the next step. And what we're going to, milligrams, is going to go on the top. So now we're going to look at our conversion chart to see how many milligrams and grams are equal to each other. One thing, when you're doing these conversions, the unit that has the prefix, so for example, the milligram, will always have a 1. But we need to know how many grams are equal to that 1 milligram. So if we switch over to our other chart, and it says milligram, or it says milli, but we can apply gram, meter, whatever. So milli, and then this is how many milligrams we'll have. So 0.001. So if we come back, then we'll put 0.001 for that bottom with the grams. Now, since milligrams is what we were looking for, and that is in the top of our problem, we are ready to solve. So when you have your equation written out like this, you're going to start with the number given, the 5.712, and then anything across the top you will multiply. So we would do 5.712 times 1 divided by anything that's on the bottom. So divided by 0.001. And that's going to give us 5,172 milligrams. Now you might say, well, I can just move the decimal. I know how to do that from junior high. That might be true, but later on when we do conversions that aren't just prefixes, that they might be meters to feet or something where it's not just a unit of 10, you'll need to know the system. So I'm going to expect you to do this setup as we go. So if we look at the following examples, we've got 15 meters to centimeters. So we'll start off 15 meters. Then we'll do our multiply in our line. And since meters is the unit on top, it will go on bottom. And we're going to centimeters, so that's going to go on the top. Now the one with the prefix always gets the 1. Then we're going to come and we'll look at our conversion chart. So our conversion chart says centa is equal to 0.01 meter. So we'll come back, continue on. So 0.1 meter, 0.01 meter. And then we're ready to solve. So if we've got a 1 on top, now we just need to divide what's on bottom. So 15 divided by 0.01 is going to give me 1,500 centimeters. Now if we look at the next problem, we've got 3,424 kiloseconds. So I'll write that down, 3,424 kiloseconds. Do our multiply and our line. Kiloseconds is on top, so that goes on bottom. And we're going to seconds, so seconds goes on top. Unit with the prefix gets a 1. Then we come and look at our chart to see kilo means 1,000. So we can come back and we'll look at 1,000 goes with the seconds. And we're ready to solve. So 3,424 times 1,000 because it's on top, and we only have a 1 on the bottom, so we don't have to worry about dividing. So we get 3,424,000 seconds. Now the last one, we've got 56.3 grams. and we're going to centigrams. So grams on bottom, centigrams on top, and again, 1 with the centa. And we did centimeter up at the top, so centigram, we would have the same amount. So 1 centa is 0.01 grams. And now we're ready to solve. So 56.3 divided by 0.01 is going to give us 5,630 centigrams. So here's our friendly chemistry cat. I like to throw him in here. He's got some wise words on chemistry every now and then. So I realized I weighed nothing on a milligram scale. I was like, OMG. Our next problem, we're going to start with 16.45 meters, and we're going to go to kilometers. So we have 16.45 meters. And since meters are on top, they go on bottom, and we're going to kilometers, so that will go on the top. Prefix gets a 1. We come look at our conversion chart for kilometers. Kilo means 1,000, so we'll come back. And so meters, we'll put 1,000. And we're ready to solve. So 16.45 meters divided by 1,000 gives us 0.01645 kilometers. On the next one, we've got 0.014 milligrams, and we're going to go to grams. So we had, trouble here, guys. Okay. So we've got 0.014 milligrams, and we're going to grams. So milligrams are what we're starting with. They will go on the bottom and grams on top. 1 with the prefix, and then we come and look at milli is 0.001. So 0.001, and we're ready to solve. When you type this in your calculator, 0.014 times 0.001 gram, my calculator tells me 1.4 E negative 5. That E means times 10 to the whatever that exponent is, negative 5th. So I would actually write this as 1.4 times 10 to the negative 5th. If your calculator didn't do that, it would also possibly give you 0.00014, and that is grams. So either one of these answers would be correct.